Okay, 4.5 solving polynomial functions. The book tells you a bunch of these steps. Like usual, I don't always follow all the steps, but I'll do most of these, and I might come back to it and show you exactly what out of these we did do. But let's just look at an example. So this is from the last lecture, and then here are the potential zeros that we found by using the 2 and the 9 and the factors of 2 and 9. So if you have to do this by hand, so without technology, then you start with a potential zero. For example, 1 is listed. And then 1's pretty easy because, 1 to any power just gives you that number. So with a positive 1, you literally just are writing down the coefficients, and you can clearly see that that's not 0. Well, then a negative 1 would be a good one to use. A negative 1 to an even exponent would be still positive, but the odd exponents here just end up giving you the negatives. And then at least we have some cancellation. So now we just need to see, do we have enough? So that's a negative 40. And then hopefully the other ones add to 40. So 2 plus 29 is 31 plus 9 is 40. So negative 1 is a 0. That means that you can do synthetic division with it. And if you do this right, you already know that you should get a 0 here. So you probably could have started just doing the synthetic division. So drop to 2. That's a negative 2. That's 11, that's a negative 11, that's 18, that's a negative 18, that's 9, that's a negative 9, and then that's 0. So now we have a cubic, and we need to find another one of these that potentially could be a 0. So you could just go down the line and use a half and use a 9 and stuff, but you can also try some other values that you think might make more sense. So I like whole numbers. I really don't want to work with 9 because 9 is sort of large, but I'm going to do plus or minus 3. Okay, like I just said a moment ago, you could just do synthetic division right away. And the reason that I'm actually going to do synthetic division right away, even if I use a 3, so I'm hoping that 3 or a negative 3 is a 0, even if I use a 3 in here, when I have to raise it to the 4th, I pretty quickly end up with large numbers. The other thing that I'm going to do is I'm actually going to use this one. I believe they usually call that the compressed compressed polynomial. So let's pick a negative 3. So if a negative 3 here, and the reason I'm picking a negative is because I need to have some cancellations, and these are all positive. So if I pick a negative 3 here, if it is a 0 for this polynomial, then it should still be a 0 for the one that we just factored down to. Okay? So let's just try it with 2, 11, 18, and 9. And again, the reason I'm picking a negative 3 is if I had used a positive 3 here on the outside, I wouldn't get any cancellations. So, and I need somehow to make these numbers smaller. So for example, 11 minus 6 is 5. So that's a smaller number. And that's what I really needed here. So that's a 3, and that's a negative 9, and that's 0. Good. So this is now my next step, and that one, let's see, so we started with an x to the 4 here, so this one is an x cubed, and then that one's an x cubed. Well, that one's a square, and squares I can solve without doing any of this stuff anymore. So, I'm now trying to look at, well, what do I do here? Well, in that one, actually, I think factors. So let's try it with 2x and x. And 3 has to be the product of two whole numbers, so the 2 is over here, so let's try a 1 there, I mean 2 positive numbers, or 2 negatives. So let's check, so that's 2x squared plus 2x plus 3, that's 5, so that works. So that means that 2x is a negative 3, so x is a negative 3 over 2, and x plus 1 is 0, that means x is a negative 1. So actually I found all of the zeros, I believe. Okay, so let's see, what did I do here so far? Write the function in factored form. Well, I didn't do that yet. But I do know that x is a negative 1 is a 0, so that's x plus 1. And I said over here that a negative 3 is a 0, so that's x plus 3. And then the last part, actually, I did factor, so I can just copy that one. So this is the function in factored form, and then find the real zeros. So the real zeros were a negative 1, a negative 3, a negative 3 over 2, and a negative 1. So I found all of the real zeros, and it is in factored form. Okay, and that's how you can do this if you had to do it completely without technology. Okay. do want to show you here though, if those are all the potential zeros, this can take quite a long time. Okay, so you don't always have to do it by hand, but you should be able to do it. So let's look at another one. Solving a polynomial equation. And let's assume on this one that you can do this with technology. Well, so the nice thing with technology is that, obviously you can plug it in and you can maybe read off some zeros. So let's check. I think I have GeoGebra right here. There's the function. I'll slide it over a little bit. See, that's the function that we have, and there's the graph. And let's see. We have a 0 at a -3, a 0 at 2, and a 0 at 8. And now you have to look at the degree a little bit here. And I forgot to mention that in the previous one. So if that is an x cubed, you could have 3 real zeros. 1, 2, 3. So this one's it. There's nothing else here to solve for. So this particular problem is actually super easy. Okay, based on this graph, we can say that there are zeros at, do we say, a -3, a +2, and 8. Those are the zeros. Let me double check. -3, +2, and 8. Good. So that means that in factored form, this function would be a -3 becomes a +3. That becomes a -2, and that becomes a -8. And you're done. So that one's factored and solved rather quickly. Okay? Alright, so one more. And this is a great strategy for cubes, although you don't usually see this in the books and stuff. So what if you don't want to do the potential zeros? Well, a couple of zeros are always easy to use, and that would be if there's a 0 at 1 or at a -1. So if you want to know if 1 or -1 is a 0, just start with it. So let's just say, well, I'm assuming that x equals 1, because I do have a couple cancellations here, is a 0. Okay, if this is true, then if I use a 1 here and then I do synthetic division, this should work. So 1, 1, 5, 5, 3, 3, -2. So no. So we'll do the same thing, and now I'm going to just say, well, what if it's a -1? Then I could do 1, 4, -2, and -5. -1, drop the 1, -1, that's 3, -3, it's a -5, that's 5, that's 0. Great. The reason this was such a great strategy here is because it's a cube. So that means that it has, at most, 3 real zeros. So as soon as I get down here, that's a quadratic, right? That's an x squared plus 3x minus 5. And I still like writing this because it helps me with the factoring. And then I can see if it's factorable or if I need to solve it some other way. And in this case, I don't believe that's factorable. So let me use the quadratic formula actually. So it's a -b, it's a -3, plus or minus the square root of 3 squared, that's 9, minus 4, a is 1, and c is a -5, divided by 2 times 1. So what do you get? A -3 plus or minus the square root of 9 plus 20. That's 29. 29 doesn't even reduce. And now I need to put the pieces back together. So what did it say? Write the function in factored form. Okay, so in factored form, this will be x plus 1 times x squared plus 3x minus 5. So this is the factored form of that function. Okay, the reason that's the factored form, and that you don't have to break it down any further, is because the other zeros that were here, the other zeros have square roots in it, so we don't factor over the square roots. And then it also says find all the zeros, or find the real zeros, and they're sort of listed over here, but I'll list them one more time. So the real zeros are at a -1, and then at a -3 plus or minus the square root of 29 divided by 2. And that would be, on a cube, it might be worth your time to just go ahead and try it and see if you can, get this thing to work out easily by using either a 1 or a -1, because they're so easy to check with. Okay? Thank you.